Hello again, Year 9, and welcome to the next part of the course. If we'd been in school, we would have been doing electricity supply next, so there are two short videos which are going to go through the basics for you. If we were in school, we would have used a piece of equipment a bit like this. It's called a cathode ray oscilloscope, or CRO, and we use them for all sorts of things, but in this case to look at different electricity supplies. Okay, so there are two types of electricity supply, AC, alternating current, or DC, direct current. And the alternating and direct refers to the direction of the current. There's our key word. So a DC or direct current continually flows around the circuit in one direction. Alternating current, on the other hand, continually changes direction. It flows one way around the circuit and then goes back the other way around the circuit. So on the CRO, the direct current has a flat line. It's just the same current continuously. The alternating current, on the other hand, or alternating voltage, would vary between positive above the line and negative below the line, showing it's got a positive direction and then a negative direction. The supply to our homes is 230 volts AC, and it has a frequency of 50 Hertz. And frequency means how many cycles or waves per second, which means that it's changing direction. We have 50 cycles per second. We can vary two things about our AC current. The first is the amplitude. Amplitude is the height of the wave. Be careful here because by height we mean the height above that black dotted line, which represents 0 volts or when nothing is actually happening. So as the current flows in one direction, you can see it goes below the line, negative direction. And as it goes above the line, it's going in a positive direction. So the height of the wave, or the amplitude, is the height of it above that dotted line. The taller the wave, the higher the voltage. We can also vary the frequency. We have 50 Hertz to our homes, but actually you can have any kind of frequency. The higher the frequency, then the more quickly the current is changing direction. And we can see that on the CRO scan there, because the more frequent it is, the more oscillations we get per second, and so the waves appear to be bunched closer together. As well as frequency, we can measure the time period of our alternating current, and the time period is how long it takes for one oscillation to pass, or one wave to pass, measured in seconds. Now, if we look at the screen here, you can see that for one wave or one oscillation, we mean the sort of start to finish of the wave. So on the top two arrows there, I started at the top of the wave, I've gone down and up and finished at the top of the wave again. And there are 4 squares going along between the first and second arrows. If I look at the bottom, I've started the wave at the 0 line, and then it's gone up, down, through the 0 and back to the beginning again. And again, on the bottom 2 arrows, you can see 4 squares between the start and end of the wave. When I'm using the oscilloscope in the lab, I have something on there called the time base. And usually when I'm fiddling around with this, I'm trying to make sure that you've got a nice clear image with a wave sitting squarely on the screen, rather like the one in the diagram below. But in reality, the time base is there to set a scale. So it will tell me how much time each square along that scale represents. In this example, we set the time base to 2 milliseconds. Don't forget little m or milli means 1,000th, so 2,000ths of a second. Going back to what we did in the last slide, we know that the time period is 4 squares across from peak to peak or trough to trough. So the time period is 4 multiplied by 2 milliseconds, which gives us 8 milliseconds. Or if I divide by 1,000, 0.008 seconds. We already know the word frequency means the number of oscillations or cycles per second. And in fact, it can also be calculated by using the formula frequency is 1 divided by time period. The two are related. So in our example, the frequency would equal 1 divided 0.008 seconds, or 125 Hertz. So that means we have 125 cycles per second. So to summarise, our mains electricity supply arrives at our homes at 230 volts AC with a frequency of 50 Hertz. Don't forget, alternating current constantly changes direction. I've highlighted the word direction there because that's the word we're looking for in an exam question, for example. And it produces what we call a sine wave shape on the CRO. Direct current or DC current flows continuously in one direction. Again, that word direction is key. so we get the straight line on our CRO.